page 207, which situation is best represented by the graph? A rubber ball is dropped from a height of 5 feet. It bounces several times before rolling to a stop on the ground. Okay, that one would look something like this. You drop it up here from a height of 5 feet, so it's going to roll down here. It's going to bounce, and then it's going to roll to a stop. This would be the scenario of A. So I don't like A for this one. An elevator begins at the ground floor of an office building. It goes up 3 floors and remains on the 3rd floor for several minutes. Then it goes down to the 2nd floor where a passenger gets in and goes up to the 5th floor. So let's model that picture on a graph. At the ground floor, the elevator goes up 3 floors. It remains there for several minutes. Then it goes down to the 2nd floor where somebody gets on, and it goes up to the 5th floor. So that's not what we're looking at there. Leanne hikes up to a mountain peak at a speed of 2.5 miles an hour. When she reaches the top, she rests for a while and then hikes back down at a speed of 4 miles per hour. That's the one I want. And here's one way to know. You see how that slope is not as steep as this one? That indicates to me that this is a slower speed and that this is faster. The steeper the slope, the faster the speed. This is where she rested. So C is the one you want. But let's model D while we're doing this. This is good practice. This can happen also on a science test. A diver is on a board 1 meter above the ground. So the diver is right here on the board. He dives into a pool that is 12 feet deep and then swims to the surface. Actually, let me try this. Let's give me a little more room. So he dives into a pool. And then he swims to the surface. Okay. So C is the one that fits the graph they provided. All right, skill practice. Read each problem and complete the task. Describe the key features of this graph. The x and y intercepts. The x-intercepts are at -1, 1, and 3. The y-intercept is at about +3, I believe. Not quite to 4. The positive and negative intervals. Well, positive intervals are when your graph is increasing. So let me mark those in pink. There's one, and then there's one. So the positive interval will be when x is less than 0. Wait a minute, no. Well, okay. I've got myself confused. Let me think here. The positive interval. Oh, I'm getting that confused with increasing interval. I'm sorry, guys. It's after midnight. Positive interval is above the x-axis. So the positive interval is not the pink. I'm sorry. I'm batty. Let's try it this way. The positive interval is right in here. When your x's are between -1 and +1, you have a positive interval. So it's when x is in there. And then the negative interval is going to be when x is below, or let me draw it first. Here is a negative interval. And here is another negative interval. So negative is going to be when x is smaller than -1, or when x is between +1 and +3. That's the yellow areas. And then this one was a positive area. You've also got another one above the x-axis. It's going to be right there. So positive also once the x's are above, 3. So those are your positive and negative intervals for the graph. Sorry about that. I'm just batty. Increasing and decreasing. This is what I was trying to do. Increasing intervals. Let me put those over here. Remember, that's when your graph is climbing. It's increasing. And that's going to happen right here up to that point. So until x reaches 0, you're going to be increasing. So x, anything less than 0 is on the increase. And then you have a decrease from here to here. So we are going to say when x is between 0 and +2, you will get a decrease. And then we start increasing again. So we have another yellow section of the graph. And that will happen when x is greater than +2. So these two areas show increase, and then the blue area shows the decrease. Relative minimums and maximums. The relative maximum is 3, and the relative minimum is -3. All right. Number 2. I've got to sketch a graph, so let me take this over to the notebook. And let's see if we have, I don't, so let me make a new clean sheet of paper and erase all that. So we are supposed to sketch a graph that fits these conditions. It is supposed to be a quadratic graph, so that means parabola. The graph has no relative minimums. The graph has no relative... Oh, I'm sorry, each description. Excuse me, I was thinking, how can that... We got 3 different scenarios here. All right, so the first one, a quadratic graph that matches each description. A, the graph has no relative minimum. There is a possible answer to this one. If it has no relative minimum, it could have a relative maximum. So it could look something like this. So that is definitely possible. Okay, B. Let me put it right here. So I need another coordinate plane because this is a different situation. I was trying to put them all on one. The graph has no relative minimum or maximum. That is not possible because a parabola has to have one, a relative minimum or a relative maximum. So B, that's just not possible to do. C, the graph has no symmetry. That's not possible either. Not for a quadratic, because the nature of that parabola shape or parabolic shape has symmetry. It doesn't matter how you rotate it. For example, if you rotated it this way, it's still going to have symmetry. You could draw the line of symmetry this way. But the nature of the shape of the parabola means that it has to have symmetry. Otherwise, it would not be a parabola.